In this video, we're going to take a look at another example of how to establish a function using linear algebra, or the matrix method from our calculator. And we'll also take a look at some other linear equations that we can solve by hand and also with the calculator. So first things first, we're being told that a function is described as a cubic function. We have four parameters, a, b, c, and d, for which we need to solve. And we're given some clues along the way, 1, 2, 3, 4 coordinates. Now, unlike the example we did in class, we're not given an actual coordinate. We're being told that the function evaluated at -3 is equal to -123, and so on. But we can still gather the same information from this supplied data. So here we know that x is equal to -3, and when x is equal to -3, we end up with a y value equal to -123. That's what this function is telling us. So I would argue that we can set up a system of equations to solve this. We know that y is equal to -123. We don't know what a is, but this occurs when x is equal to -3. So we'll make that substitution. And we'll just simply substitute -3 in for x in each of the terms within this polynomial, this unknown polynomial. And we would just repeat that for each of the four given pieces of information. So I just paused the recording and filled in the rest of the information. So I think it's important that you try this on your own. So I would like to ask that you do this as well along with me here. And then it's important to note at this point that we can actually simplify quite a bit. Each of these four equations were established by simply interpreting the four given pieces of information here. But these equations aren't real useful for us when it comes to solving a linear equation, or a system of linear equations, I should say. So what we would like to do is rewrite this so that the matrix, if you will, of our parameters is written on the left side with the solutions on the right. That'll allow us to identify our augmented matrix, and then we can go ahead and move forward with solving this system. And so by considering what would happen after we simplify each of these substituted values, -3 cubed was -27, -3 squared was 9, and so on. Each of those could act as a coefficient in front of the parameters that are left behind. And across that top row, I now have the coefficients of -27, +9, -3, 1, because of the coefficient with the letter D. And then I'm placing the results, or the solutions, on the right side. -123 ends up on the far right. And this is our augmented matrix that we can bring to our calculator. Now, using the inspires, we've been pointing out that the shortcut is menu 7-5, menu 7-1-1. If you're using the inspires, this will activate the matrix menu and call upon the reduced row echelon form command. And within the reduced row echelon form command, we can now build a matrix. Now in this case, since we had four equations, we needed 4 rows and 5 columns. So we'll specify that, and we'll let the calculator do its work and determine the result. Now, if you don't have a TI Inspire to use, do recall that we have the software available to you, so you can install that on your computer. It'll look something like this when you're running it on your Butler Tech machine. You could, of course, purchase one if you feel so inclined, or you can continue using an older calculator or a different calculator, such as an 84, TI-84, if you have one of those. The only issues with the 84 is that I'm not that familiar with the operating system anymore, and I don't quite recall where the the keystrokes are, or what it would take to access the matrix. I could probably sit down with you and figure it out. But as we've been showing in class, we do have these options available, so that's the method that I'm going to go with here. And just to illustrate what that would look like on the calculator, here's an image of that. We entered all of the coefficients in a reduced row echelon form command. The result is a reduced row echelon form with ones down the diagonals on the left and numerical values here on the right. So the 1 in this first column indicates that this result is for A, then B, C, and D. So C is 0 here. That's kind of interesting. I think we can now report that f of x is equal to 3x cubed, 3 was the A value, minus 5x squared plus 0x, you could write that if you want, but I'm not going to, plus 0x plus 3. And this apparently is the cubic function that has all three of these coordinates associated with it. We can further confirm this by taking a look at the data points if we plot them into a graphing calculator. I'm going to use Desmos for brevity here. So I took the time to enter the four coordinates. There was one that's hanging out way down low here. Here's the function that we established, 3x cubed minus 5x squared plus 3. And if I turn that function on, it sure looks like that graph strikes each of those data points. Now if we zoomed in or even checked our math one more time on the calculator, let's see if I can get this to work, we can ask f to be evaluated at 2, for example, and Desmos does recognize that the result is 7, like we had anticipated. And that would work for each of our function values here, had our work been done correctly. And I feel fairly confident. So hopefully that helps with this example. I'm going to create another video to walk through 2 more examples that would be helpful for this quiz this week. This unit test this week.